Hello, all. Good morning. Welcome back.
Good morning, sir.
Good morning, sir.
Today we are going to discuss about introduction to servers and networks. Right? So we completed last 3 demos, right? We completed 3 demos in last week, right? Yeah. So anyone having any questions on that? So we completed DevOps demo and question and answers, cloud introduction. 3 sessions we completed, right? So anyone having any questions on that before going to servers and networks introduction? Fine. Yeah. So here agenda is what is server? Before going to DevOps, we need to understand these basics. Okay. Before going to cloud. So once we complete this basics today and tomorrow, day after we'll start AWS. Slowly we'll enter into the AWS. Okay. Once completed AWS, then we'll move to Linux and DevOps. Okay. Yeah. So here in this session, we'll try to understand what is server, types of servers, server client model, best practices, and server architecture, what is operating system, types of operating systems, what is network, types of networks, what is IP address, subnet, gateway, router, firewall, failover, and load balancer. So these things we are going to cover. So up to here we can cover today, up to operating system, right? From networking we can cover from tomorrow, right? So this up to here it will take 1 hour, okay? So types of operating systems up to here it will take 1 hour, right? Yeah. So basically, what is server? Anyone? What is server? Any real time guys? What is server? Right. So a server is a
It's
computer
a
that
network
serves.
where we can store the data.
Right. So when we talk about server, this is high capacity unit, right? So normally every developer tester will directly connect to the servers. So a server is a computer that serves information to other computers called clients. Unable to listen. Yeah, can you check your connectivity? I think Kalyani is she's unable to hear me, right? Everyone hear me, right? Can you hear me, everyone? Can you confirm anyone?
Yes, sir.
Yeah.
Yes.
Yes, sir.
Yeah, Kalyani, can you check your speaker internet connectivity? Yeah. So a server is a computer that serves information to other computers called clients. Clients means desktop or laptop. That is a client. So called clients can connect to a server through either a local area network or a wide area network. Local area network means LAN cables, LAN network, right? So such as the internet, right? So normally from laptop or desktop, we connect to servers to work on the activities, automation activities, code movement, code merging, code pulling, code pushing. So normally as a DevOps engineer, what we will do, we'll connect to servers. Even though developers also they connect to servers, right? Testers also they will connect to servers, they test the code, right? Yeah. Next one, types of servers. So first one is blade server. So blade server is a small unit. It is a high performance server. So we'll be having one container. Instead of the container, we'll set some blade servers, thin layers, thin servers, right? So when we insert blade servers here, so these servers will communicate through network. Okay. So blade servers are a bit costlier compared to other servers, right? Let us go one by one. See here, blade server. A blade server is a modular server that allows multiple servers to be hosted in a smaller area. So these servers are physically thin, typically only have CPU, memory, integrated network controllers. So these servers will have only CPU, memory. some servers will have storage also, right? And sometimes storage drives built in. So blade servers are often seen in large data centers. So enterprise level, we see this blade servers. So these are a bit costlier. Okay. Next one, rack servers. What is rack server? A rack server is a server mounted inside of a rack. Rack servers are typically general purpose servers that support a broad range of applications and computing. So most of the organizations, they are using rack servers. These are the traditional servers. Okay, to deploy the applications, to run the applications, we use rack servers. So most of the data centers, we use rack servers. Okay. Next one, tower server. What is tower server? A tower server is a computer that is built in an upright cabinet that's standalone and that is designed to function as a server. Yeah, normally tower server means what will happen here? So one upright cabinet will take, in that only we insert one server. So for that upright cabinet, we'll be having one monitor, one keyboard, one mouse, right? Yeah, this is a bit older server. Tower server is bit older server, right? So these are the types of servers available. Next one, client server model. Yeah, this is the client server model. So through desktop or laptop, we connect our servers through network. So when we send the request to the server, we'll get the response from the server. This is client server model. So another way, from laptop or desktop or tab also can connect our servers through internet. Client server model, right? Next one, server architecture. So we'll try to understand server architecture. So what is server architecture? Server architecture is the foundational layout or model of a server. So based on which a server is created and or deployed, it defines how a server is designed. Okay. Yeah. Now let us go and see something here like server architecture. Yeah, in server architecture, initial stage of implementation. Initial stage of implementation. In 90s and early 2000, how was the server architecture? We'll try to understand, right? So in the 90s and early 2000, the server architecture was like the project teams used to implement, like, for example, I have 4 applications are there, like Java, Git, Maven, and Tomcat. These are the 4 applications are there, right? So in 90s and early 2000, how the project teams used to build the servers. Okay, yeah. So I have 4 applications are there. Yeah, in 90s and early 2000, the project teams used to take, for each application they used to take one server, single server. For each application, they used to take servers like this. Okay, so in 90s and early 2000, highest capacity of the storage is 1 GB. By the time, highest capacity of the storage is 1 GB. So these are the 1 GB servers, for example. These are the 1 GB servers, right? So in 90s and early 2000, the project teams used to deploy applications like this: one application, one server, right? For example, so here they deployed Java. Java will take, for example, 300 MB, right? So remaining space will be wasted right here. So Java will take the space 300 MB only. So remaining 600 MB will be wasted right here. 600 MB. Next one, Git. Git will take 400 MB, for example. So remaining 600 MB will, yeah. So here 700 MB, right? 700 MB will be wasted here. Yeah, Git will occupy 400 MB. Remaining space will be 600 MB will be wasted here. 600 MB, right? So next one, Maven. So Maven will, these are the DevOps tools, right? So Java is application, Git and Maven, Tomcat, these are the DevOps tools. Now Maven. Maven will occupy, for example, 500 MB. Remaining space will be wasted here. And also Tomcat. Tomcat will occupy, for example, 600 MB. So remaining 400 MB will be wasted here. Right? So like this, project teams used to take the servers for each application, one server, right? So here in 90s and early 2000, hardware costing was very higher by the time. So if any project team wanted to buy any hardware like desktop or server, it was very higher costing, right? So here what will happen? What is happening here? So server costing is high, but utilization is very less. So here only Java only one server, right? So 300 MB only utilizing here, remaining space will be, it is wasting, right? So like that, utilization is very less, costing is more. That is why this model is failed. This is failed concept. This concept is failed. This is failed concept, right? So that is why, yeah, slowly after 2000, so the project teams used to follow other process, which is in second phase of implementation. In second phase of implementation, project teams used to follow other method, which is like so project teams used to take one higher capacity server like this. Okay, so in this they used to deploy all the packages like Java, Git, Maven, and Tom, like this, right? They used to take higher capacity server. They used to deploy all the applications on single server. Okay, so here what will happen? Java team will access, Java user will access Java application, Git user will access Git application, Maven user will access Maven application, Tomcat user will access Tomcat application. But here, what will happen? There may be chances to access, Java user can access Git application. There may be chances. Git user can access Maven application. Maven user can access Tomcat. There may be chances to access because all the users are connecting to same server. All the applications are deployed on single server. There may be chances to access other applications also. For example, 4 people are staying in one flat. Okay, so 2 are staying in one bedroom, 2 are staying in other bedroom. The 4 people can commonly access kitchen and dining, right? Because accessibility is there. So the same way, Java user may access Git application, Git user may access Maven application. So Tomcat user may access Maven application, like that, right? there may be chances. That is one drawback. And also, one more drawback is if the server is crash, what will happen? The server is crash. All the applications will be gone. Crash means corrupted, right? So if the server is crash, all the applications will be gone. That is major drawback. Okay, so that is why second concept also, second phase of implementation also failed here. This model also failed, right? Next one, later in third phase of implementation, so virtual servers came into market. Virtual servers, virtualization, VMware, Citrix, hypervisor. These are the virtual servers. Okay. So in third phase of implementation, virtualization, virtual servers. What is virtual server? Anyone? Anyone having idea? What is virtual server?
Means single server having multiple IPs and multiple access. Like it is a physically only one server, but we can divide it in multiple server as a virtual. Like we can allocate separate CPU, RAM, storage, everything.
We take one physical server. On top of that, we create virtual servers, right? Yeah. How can we create virtual environment? We'll try to understand here. For example, in third phase of implementation, this is one physical server. We can say base OS. This we can say base OS, base operating system, right? So this is base operating system. This is physical server, simply, right? So on top of this, what we will do? We deploy some package, some virtual software, which is like VMware or hypervisor or Citrix. So these are the virtual softwares. These three are virtual softwares. We can install on the physical server. Once we install the software on physical server, this will allow you to create virtual servers. Okay. So on top of this, what we will do? We create virtual servers. Like this, right? See here. So we created 5 into 5, 25 servers. Based on your physical server capacity, we can create virtual servers. So whenever we create virtual servers, this virtual servers will utilize resource from physical server only, right? So here, what we can do, we can deploy different packages, different operating systems here. So these are the different servers, virtual servers. Here I can install Windows 2016. Here I can install Linux, Ubuntu. Here I can install CentOS Linux different flavor. Here I can install RHCL Linux flavor. Here I can install Windows 2019. Whatever operating systems you want to install, you can install like this. So these servers will be utilized resource from base OS. So this physical server, base server, will be having higher capacity hardware like RAM 48 GB, CPU 32 core CPU, and hard drive 10 TB, like this. So higher capacity hardware will be there. So these servers will utilize the resource from physical server. right? Yeah, here still we are using virtual servers in data centers. Currently we are using cloud servers. Along with that, we are using virtual servers also, right? Now, here also we have some drawbacks. Okay, so when you want to create any virtual server, what we will do? We use ISO image. What is ISO image? Anyone? For example, if you want to install Windows on your laptop, we use one image, right? We copy into pen drive, we connect the pen drive, and we install the operating system in laptop. The same way, server level also we use ISO image. ISO full form is International Standardization Organization, right? So this is a full package of the image, full operating system, right? So for example, if you want to install Windows 2016, right? So minimum size, the operating system size is 14 GB. This Windows 2016 package size 14 GB. So the same way, if you want to install Ubuntu 12 GB, CentOS 8 GB, RHCL 6 GB something. So Windows 2019 will take 13 GB something. So like that, every operating system will have some space, right? So here 5 into 5, 25 servers we are installing operating system. So minimum 8 GB to 16 GB space will be utilized for only one operating system. So here we have 25 servers, right? 25 into, for example, 25 into 10 GB on an average, 10 GB equal to 250 GB for only operating system. So this much of storage we have to spend for only operating system. So on top of that, again, we install software, right? Tools like Java will be installed, plugins will be installed, Git will be installed. It will take more space. Okay, this is one drawback. Storage will be utilized more in the virtual environment. And also, when you restart this server, when you restart this virtual server, okay, it will take minimum 4 to 8 minutes. When you restart any virtual server or physical server, it will take minimum 4 to 8 minutes. That much of time client will not accept, because, for example, Flipkart application is running on one server, for example. If you down that Flipkart server, application will be down. Globally, application will be down. Business will be impacted, right? So 4 to 8 minutes means it is very highest time, right? So client will not accept to down this server this much of time. Okay, so this is one more drawback. And also deployment time and downtime is high. So when you want to deploy any packages on the VMware servers, it will take some time, right? So when you want to restart, when you want to down means, what is downtime? Downtime means maintenance time, right? So when you want to down the server, so client will not accept because it will take some time to restart the server, right? So deployment time and downtime is very high in the virtual environment. That is why this concept also not successfully and we are using in real-time projects. But here we have some drawbacks. In this environment, we have some drawbacks. That is why project teams are looking for advanced environments which are like Docker architecture, Docker servers, Docker infrastructure, Docker infrastructure. So clients are looking for, right? So now this is very advanced. Docker, Kubernetes, these are very advanced, right? So currently project teams are using Docker and Kubernetes, right? Yeah. Now something you're seeing. Something you are saying. Docker, about Docker, right? Okay, fine. Now, this is Docker server. Docker server. So this server can be physical or virtual or cloud server, any server. So on top of this, what we will do, we configure Docker image, same as ISO image. Okay, Docker image. This Docker image will allow you to run the containers. In Docker, what we will do? We run containers. On top of this, we run the containers like this. Here we can run different operating environments like Ubuntu, RHCL, CentOS, Windows, like. So these are the containers. In Docker, we don't call it as servers. These are the containers. So containers is nothing but just like box. We can move anywhere, we can use anywhere. So this is a lightweight environment. This is a lightweight environment. So this is not like server. So when you want to operate a system on the virtual server, it will take minimum 8 GB to 16 GB. But when you want to run the container, how much size it will take? Just it will take 200 MB only. When you want to run the container, it will take 200 MB of the size. Got it, right? So here in the container, only lib and bin files will be created. Once we run the container, only lib and bin files will be created in the container. It is a lightweight environment. So currently we are using online shopping, right? If you want to book any product, we book the product through Amazon shopping site or Flipkart. So when you book the product, that will be delivered within 24 hours, 6 hours, 4 hours also. So because backend there is a Docker and Kubernetes. Currently, most of the people they are using online shopping only. In pandemic time, lockdown time, everyone used only online, right? So online is very faster now because backend there is a Docker and Kubernetes. So lightweight environment. When we book the product, the order will be placed immediately, right? So within few hours it will be delivered, right? So recently I booked one mobile, OnePlus mobile. Within 4 hours they delivered. Because backend there is a lightweight environment. So microservices, these are Docker Kubernetes available backend. It's a very faster. So if they use physical servers or virtual servers, that is not faster, right? So here when we use Docker containers or Kubernetes, that is very faster, high speed, right? So when we run the container, it will take only 200 MB of the space, but here GBs, so less storage here. Whatever minimal configuration, whatever minimal files are required, those will run in Docker. But here physical environment, full package, right? And also when you restart the container, it will take 15 seconds only. But when we restart here, this servers 4 to 8 minutes. So here in Docker, 15 seconds only, within 15 seconds, containers will be restarted, right? Yeah, and also deployment and downtime is very less here. Deployment time and downtime is very less because lightweight environment. When you want to deploy any applications, very quickly deployed in Docker containers. When you want to restart containers, will take very few seconds only, right? So this is very faster, higher speed. That is why project teams are looking for Docker containers. Currently, we are using digital applications, right? Like Flipkart, Amazon shopping site, Reliance Trends, Meesho, different digital sites are. Those are deployed on Docker and Kubernetes. That is why. So those are very faster. Clear, right? Any questions, anyone? Any questions from here, anyone?
Hello, Ram.
Yeah.
Hello. Each container working as each server, right? Here.
Each container work as each unit.
In,
That is not server. Containers are
okay.
not servers. It's just like box. So
Okay.
in Docker we use microservices. What is microservice? We'll try to understand. For example, Flipkart is there. Flipkart.com. Okay. So in Flipkart.com, for example, if you click on home and click on any product here. So these are all microservices. These are all microservices. Okay. So microservice means one small service. Each service will be deployed on one container. For example, here we have bed sheets are there, for example. These are all microservices. So this is one microservice like this. These are all microservices. Okay. So here what will happen backend? In backend, what will happen? So whenever developers want to modify any script on the microservice, they will log in particular container. Why they modify script here? Because pricing will be changed. They give some offers. So this is they give some offer here, right? And also sometimes what will happen? This product is not available, out of stock. They will modify it out of stock, or else they give more percent of the discount, like that. So whenever they want to modify any microservice, backend they log into the container, they modify the code. Developers. So we don't develop anything. As a DevOps engineer, we don't need to develop any code. As the DevOps engineer, what we will do? We maintain these containers. We create the containers, we maintain the containers. It's very simple. To create the containers, very simple. So when we discuss about Docker, we'll go deep dive. So just high level architecture this. So I'm explaining high level architecture, right? So when we work on Docker, it will take 6 to 7 days Docker. So by the time we'll go deep dive. Okay. Yeah. So backend developers will modify this microservices. Fine. And in Docker, we have two types of applications are there. Loosely coupled, tightly coupled. Tightly coupled means, so one microservice is down, entire application will be down. Loosely coupled means all microservices will work individual. One component is down, application will not be down. For example, in Windows, if you open here Task Manager in Windows, we have services right here. These are the services, different services. So if any one service is down in Windows, or Windows will not work properly. That is tightly coupled, right? So all the services should run. Otherwise, Windows will not run properly, right? But loosely coupled means all the components will work individual. One component is down, nothing will be happen. So Docker is implemented in loosely coupled, right? Yeah. So we'll discuss about that when we talk about Docker. We'll go deeper. Okay. Fine. Any questions up here, anyone? This is high level architecture. So while working on Docker, we'll go deeper. So Docker is very advanced concept, right? Kubernetes, Docker is currently
Sir,
hot.
sorry for interrupting.
Yeah, go ahead. Yes.
Sir, for Docker and Kubernetes, I think like VMware and all VR application for using for virtualization. So we need to take a license like for VMware and
Yeah,
Hyper-V. Similarly, for Docker, we have to take a license, or it will be open source.
yeah, it is open source. So enterprise level licensing will be there. Enterprise level licensing will be there. You need to, in real time projects, license versions only we use. We don't use freeware.
And sir, okay, sir. And sir, if we want to practice this Docker and that in our personal laptop, is it possible we can make it?
Normally, we don't install Docker on laptop. We create cloud server, AWS server. In that only, we can create the Docker. We can connect cloud, AWS, we can practice in the AWS.
No, there is we can do it. I'm
Ah,
just asking.
if you want to install, you can install in your laptop also, but that is a bit
Okay.
slower when you install in your laptop. So because,
Mhm.
yeah, cloud servers we use currently, we are using cloud servers. Okay, fine. Clear, right, everyone? Yeah, next one. So these are the different phases of implementation. We discussed about server architecture. So far we discussed about server architecture, right? Yeah. So this is the server architecture, different way. So this is physical traditional environments. So we'll go deep dive later point of time. So when we discuss about this, right? Next one, what is operating system? What is operating system? Anyone? What is operating system?
It will be the set of the program or software which we can operate the user-friendly environment. It's allow user to interact with the different like Windows Server, Windows OS, Linux OS, Ubuntu, all are the operating system.
Right. So operating system is an interface between user and the computer hardware. Operating system is an interface between user and the computer hardware. Right. So hardware will understand only binary language. Right. So what is binary language? Binaries. What is
Machine can
binaries?
understood that language that is called binary language 0 and 1.
Zeros and ones. Binary language is zeros and ones. 000 001 010 111 100 like that, right? So hardware, computer hardware will understand only binary language, but human will not understand that. That is why we require one translator, which is nothing but operating system. Operating system will translate binary language to human readable language and vice versa to effective communication, right? See here, definition is operating system is an interface between user and the computer hardware. The hardware of the computer cannot understand the human readable language and as it works on binaries, that is zeros and ones. So in such case, we need an interface which can translate human language to hardware and vice versa for effective communication, right? So operating system is a translator. It is a translator, mediator, right? See here. So between hardware and end user, this will work as a interface. Operating system will work as a interface, right? Next one, types of operating systems. What are types available, right? Yeah, first one, single user, single tasking operating system. Single user, single tasking operating system. In this type of operating system, only one user can log into the system. He can perform only one task at a time. So for example, which is MS-DOS, Microsoft Data Operating System. This is old operating system. So in this operating system, one user can log into the system and he can perform only one task at a time, which is nothing but single user, single tasking operating system. Right? Next one, single user multitasking operating system. In this type of operating system, only one user can log into the system and he can perform multiple tasks at a time. So this is Windows. In Windows, what we will do, server level, for example, or laptop. Okay, one user can log into the system and he can perform multiple tasks while working on, while browsing internet. He can run background audios. while working on some paint brush, you can run background audios. Like that, one user can log into the system and he can perform multiple tasks at a time, right? So which is nothing but Windows. Next one, multi-user multitasking operating system. What is this? Yeah, in this type of operating system, multiple users can log into the system and they can perform multiple tasks at a time, which is nothing but Linux and Unix. Yeah, in real-time projects, while deploying the code, developers will log into the servers, testers will log into the servers, DevOps engineers also will log into the servers, right? So multiple users can log into the servers, they can perform their own activities in the real-time projects, production environments, right? So these are the types of operating systems: single user, single tasking operating system; multi-user, single user, multitasking operating system; multi-user, multitasking operating system. In this, we have different flavors: Linux, Ubuntu, RHCL. Those are the flavors versions. Windows different flavors: 2012 R2, Windows, right? Windows 2016, 2019, 2022 also available, right? Yeah, these are the things available. Fine. Any questions up here? Anyone? Next one, networking concepts. We'll start tomorrow. This, okay, because it will take 1 hour. Networking concept, so which is very important. Okay, so types of networks: LAN, WAN, MAN, different types of network, right? And also, what is gateway? What is IP address? What is router? What is subnet mask? Subnet mask ranges. Okay, failover. What is failover? What is a load balancer? So we'll see tomorrow, right? So whoever not registered so far, who are not added to WhatsApp group, you can add today itself. Okay. So otherwise, tomorrow onwards, link will be completely changed. You cannot access. Okay. So today, same link we provided, right? So tomorrow it will not be accessible. Whoever not added to WhatsApp group, whoever not clear the fee, you can clear by today, so that you will be added into WhatsApp group. In WhatsApp group already, nearly 30 members added. Okay. Yeah, so you can clear the fee by today, and you can send the screenshot to me. I'll add into WhatsApp group. Okay. Any questions, anyone? Any doubts so far?
Sir, can
Every
you share
session,
previous videos?
yeah, I'll provide that. Previous videos I'll provide. Okay. So maybe tomorrow or day after I'll provide all the videos, previous videos.
Okay.
Fine. Yeah. And every session will be like this only. Very clarity will be there. So these are the very basic things. That is why we are theoretically understanding. So these concepts are older concepts, right? But if you understand this, you can easily understand DevOps classes, DevOps and cloud, right? Fine. Any other questions, anyone? So tomorrow we'll work on this networking concepts. So which is these are very important.
Hi, sir. Good morning. Are you going to provide any material or document for all these concepts?
Yeah. From AWS onwards, I'll provide you all the documentation. Once we start the AWS, day after tomorrow, we'll start AWS. Okay. So AWS onwards, I'll provide all the concept documents, soft copies. I'll share in the group. You can download
Okay,
it to
sir.
your laptop and you can refer them. Fine.
Sure, sir. Thank you.
Fine. Yeah. Whoever attending classroom, you can clear the fee bill today, so that from tomorrow onwards, our people will come and check. Okay. So you can clear by today. Fine.
Hi, sir. Hi, sir. Good morning. This is Mihas. Actually, I was trying to pay my fees for enrollment, but I'm not able to do that. Is there any way I can pay in like PayPal or any other way?
PayPal, I think, yeah, you check the document, right, which we provided. In that, it is not available.
Yeah, I did already with Zoom, but that transaction was canceled. I'm from US, so it was giving me so much hard time. I send a screenshot, but I don't get any answer yet.
As per the document, from US also few people paid actually through Zoom only. Can you try today once? You are
I will
unable
try
to
that.
do that?
Yes, because I never use the Zoom with PayPal. So it was go through a process, and after like 2 minutes later, it was transaction was cancelled. Yeah, I did twice. So I will try again. Is any other way I can pay directly to the PayPal with any other email? It will be good for me.
Yeah, through credit card also can pay. Through credit card, so online payment also can be done online.
Credit
Yeah,
credit card, but it was transferred to the HDFC bank, something like that. So I was skip that. So that's why.
okay. Okay, you can reach out to me if you're facing any issues. You can reach out to me. I
Okay.
think yeah. Hope everyone having my number, right? My
Yes,
mobile
yes.
number is yeah. You can call me or WhatsApp me. So if you are still facing any issues, you will see that.
Okay. What time until what time I can call? Because now is our time is almost 11:20 night time. So what time until I can call?
Your time, early morning time, maybe
Oh,
6 p.m. IST.
okay, 6 p.m. IST. Okay, okay,
6
no
p.m.
problem.
IST.
Okay.
Your
Yes, no
early time,
problem.
tomorrow morning.
Okay, no
Okay,
problem. Okay, thank you, sir.
fine. So we stop here. Any other questions, anyone?
Sir, offline and online classes both the same time, this time.
Both are same. Yes, offline, online, both are the same.
Okay. Because
And
when I have the week offs, is it possible to attend the offline?
which one? Can you come again?
Actually, when I get, today and tomorrow my week off, so is it possible to attend the
Yes,
offline class
yes, yes.
tomorrow?
You can come down. Yes,
Okay, sir.
fine. Yeah. So we stop here. If you have any more, if you have any queries, you can WhatsApp me. You can call me. But make sure you can clear the feedback today, so that link will be provided. New link will be provided. Okay.
Okay, sir.
Fine.
Thank you. Have a good day.
Yeah. Fine. Yeah. Thank you all.